students, how are you all doing? I trust you're keeping safe. This is your chemistry teacher, Miss Constance Onwuna. I'll be doing a continuation of the virtual class that will be sent to you through WhatsApp platform. So this is the second part of the topic. We've been looking at redox reaction, that is oxidation and reduction reaction. The last class we were able to define a redox reaction. We also looked at oxidation numbers and how to calculate oxidation numbers. So today we'll be looking at the second part of the topic. And okay, these are lesson objectives for today. Okay, the first one, we'll write redox half reactions, stating the oxidizing and reducing agents. And then we'll perform some chemical tests on oxidizing and reducing agents. And finally, we'll look at we'll be listing and explaining some types of redox reaction. Okay, so I'm going to start right away. But let me just remind you from our definition the last time. We defined redox reaction as a reaction that involves the transfer of electrons from one atom to another. Okay. So we're looking at redox half reactions. We looked at some examples of oxidation reaction and reduction reaction. Let me also remind you again that oxidation means loss of electrons, while reduction means gain of electrons. Okay, so today we'll be writing the redox half reactions. And what are redox half reactions? These are reactions that show how electrons are transferred from one atom to another. These are reactions that show how electrons are transferred from one atom to another. They show the process of oxidation and reduction. Okay, so I've been able to draft out two examples to explain the redox half reactions. Okay, so the first one reads, magnesium reacts with zinc chloride in this reaction. This is the reaction. You have magnesium reacting with zinc chloride to form magnesium chloride and zinc. Now the question is, identify the oxidation and reduction half reactions, oxidizing and reducing agents. Okay, so in this question we'll write out the redox half reaction and also identify the oxidizing and reducing agent. So I'm going to do it here. Now the first one, we'll have solution. Okay, so first thing you will do is to write out the equation of the reaction. Write out the equation of the reaction first. Equation is magnesium plus zinc chloride is an aqueous form, produced magnesium chloride, in aqueous form, plus zinc, then you have solid. Now of course you know that this thing means the state of the elements of compound. Okay, so this is the reaction. Okay, so now we will be identifying the oxidation and reduction half reactions. Now the first thing you will do is to check if the elements are balanced, if the ratio is the same, the ratio of the reactant is the same as the ratio of the product. Okay, now looking at this, magnesium here is 1, magnesium here is 1, so magnesium is balanced. Zinc is 1, zinc is also 1, is balanced. Now chlorine is 2 and is also 2 here, so it means this reaction is balanced. There's no need adding any other thing. Okay, so right now we will be writing out the oxidation and reduction reaction. Now let me remind you, oxidation happens when an element loses an electron, that is oxidation, while reduction happens when an element gains an electron. Okay, now another point you will note is the oxidation numbers. Our last class we calculated oxidation number. So it is from the oxidation number you will know which of them is donating, that is giving out electrons, and which of them is what? Receiving. Okay? Now, how do you know that? Oxidation number. Let me remind you again. I told you in our last class that elements standing alone, that is uncombined states of elements, the oxidation numbers are always 0. Okay? Now, from this equation, you would notice that magnesium is standing alone, and I told you in our last class that elements standing alone, that is when they are not combined, the oxidation number is always 0. Now, here magnesium, zinc is combined with chlorine, so the oxidation number of zinc here is +2. Here is what? -1. Use the method I use in calculating oxidation number to get them. Now, for the product side, you also check. Okay, so here magnesium is +2, zinc is still +-1. Here chlorine is -1, then the zinc is what? 0. Okay. Now, if you're able to write out the oxidation number, it is easy for you to know where oxidation is happening and where reduction is happening. Okay. Now, magnesium moved from 0 to +2. It means there is an increase in the oxidation number. Okay. Now, zinc here moved from +2 to 0. It means there is a decrease in oxidation number. And now let me remind you again that oxidation is the increase in the oxidation number. The increase in the oxidation number, it means this element is the one undergoing oxidation. So, okay, so you bring down this. Alright, so magnesium changes to this because it's lost 2 electrons. Okay, now if it loses 2 electrons, it becomes 2 positive. Alright, now you include the electrons lost. How many of them? 2. Okay, so this is the half oxidation reaction. Half oxidation reaction. Now, what happens to zinc? Okay, of course, in redox reaction, when you have one element giving out electron, there should be another one receiving the electrons. Okay, now zinc ion receive the 2 electrons from magnesium to form zinc neutral. Okay, so this is, because this is the half oxidation, okay, half oxidation reaction, then this is the half reduction reaction. Okay, so here you have magnesium releasing 2 electrons to form this magnesium ion, and then zinc is accepting it to form a neutral zinc. Okay, now another thing you look at is what and what is common between the 2 equations. Now the commonest or what is common between them is 2 electrons and what? 2 electrons. Now what do? You add the equation together first before you cancel out. So you have this plus this. So you write everything here, the left hand side, to give you this plus zinc and then plus 2. Now 2 electron here, 2 electron here, what do? You cancel out. Okay, now we're writing the overall equation. So the overall equation becomes this plus this, give you this plus zinc. Okay, so this is how to write the half reduction and oxidation reaction. Now, a point I want you to note is that for oxidation, the half reaction comes by your right hand side. That's if you're facing like this, or if you're facing me, is your left hand side. Okay, so the electrons will be here, Whereas for reduction, the electron will be here because it is receiving. The one that is giving out, it will be at the product side, while the one that is receiving the electron will be at the reactant side. Okay? Having gotten that, iron metal reacts with chlorine gas to form iron 3 chloride in the reaction. So you have iron here plus chlorine gas. Here is iron 3 chloride. Now identify the oxidation and reduction half reaction, oxidizing and reducing agent. So we'll apply the same method. What do you do first? Write out the equation. So you have your iron plus chlorine gas, because the gas, to produce iron 3 chloride. Okay, now this is solid, right? So this is your reaction. The next thing is to know if the reaction is balanced or not. Okay, so here you have 1, you have 1 here. Here you have 1 of iron, but our chlorine is now 3. What do you do? Now the easiest way to balance this is to add 2 in front of this. Now if you add 2 in front of this compound, chlorine is now 6, okay, and iron becomes 2. So you quickly balance the iron by adding 2 here, and then chlorine is 6 here, so you add 3 here. That means 3 times 2 will give us 6. Now the reaction is balanced. The next thing is to write out oxidation and reduction half reaction. Now look at it again. I told you in our last example that you check the oxidation numbers, okay? And check from there, you know which of them is undergoing oxidation or reduction. Now here, because iron is standing alone, it is 0. Chlorine is standing alone here, oxidation number is 0. Now iron is plus 3 here, whereas chlorine is still minus 1. Okay. Now look at the oxidation number. You're having 0 to plus 3. What is happening there? There is an increase in oxidation number. That means it is oxidation. Okay? So you write out the oxidation half reaction first. So you have iron going to iron 3. Okay? Now what happened? It donated 2 electrons. So you include the electrons there. 3, sorry. Donated 3 electrons. Okay, this is for the half oxidation reaction. Now the next one, of course, chlorine is 0 here, and now it's minus 1. It is reducing. So it is reduction reaction. What do? Write chlorine here. Of course, if it is reducing or reduction reaction, you know that it is by your left-hand side. So chlorine receive. Now another thing I want you to note is from 0 to minus 1. How many? Just 1. Don't look at because you have 3 here now you want to write 3 is receiving 3. No. Now from 0 to minus 1 is just 1. So you're having more than 1 chlorine atoms. So each of them will take in 1 electrons. So you have 2 electrons here. Okay? Now, to give you chloride, of course, how many chloride? Because there are 2 chlorine, you have 2 chloride. Alright, having gotten this, the next thing is to balance the electrons. Because here now is 2 and here is 3. What do you do to this one to make it the same as this? Now, mathematicians, what should come to your mind is, how do I make 3 and 2 the same? You just multiply this whole equation. Multiply this equation by 3. Now, if you multiply that equation by 3, you have 3 chlorine gas plus 3 times 2 will give us 6 electrons, and then, of course, 6 chloride. Alright? Now, this is 6 and this one is 3. What do you do to this one to make it 6? Multiply this equation by 2. So you come down here, times 2. You have 2 iron, give you 2 of this plus 6 of this. From our last example, what do? Add the 2 equations together so that you can remove whatever thing that is the same there. So you have Cl2 plus 6 electrons plus 2 of iron, give you 2 base plus 6 chloride plus 6 electrons. Now this is your reaction. This and this the same. Cancel this, cancel this. What do you have? So you write the iron first. 2 iron plus 3 chlorine gas. They give us 2 iron 3 plus 6 chlorine. So this is our overall equation. Okay? This is our overall equation. Now, we have been able to write out the half oxidation reaction and half reduction reaction. This one is a half oxidation reaction and this is a half reduction reaction. And this is the overall equation. Now, what do we do next? Identify oxidizing and reducing agents. Of course, from what I told you, the one that is donating electron is the reducing agent, while the one that is gaining electron is the oxidizing agent. Now, because iron donated, iron is now the reducing agent, and then chlorine is the oxidizing agent. Now, this is for half redox reaction. Now let me state a point to you. Metals are said to be reducing agents. So if you come across metal in any reaction at all, and they're asking you which of them is reducing agent or oxidizing agent, because there is a metal there, that metal is the reducing agent, and the other one is oxidizing agent. Now, non-metals are always, they tend to be oxidizing agent because they don't like giving, they like collecting. So they are always oxidizing agent. Take note, in case you see them in a reaction, you're seeing a non-metal and a metal. The metal becomes the reducing agent and the non-metal becomes the oxidizing agent. So now let us look at, let us quickly go into some chemical tests to show oxidizing agents and reducing agents. Perform some tests for oxidizing and reducing agents, okay? So I have here tests for oxidizing and reducing agents. So before I go into the test, I'm going to list out some reducing agents and oxidizing agents, okay? So here we have oxidizing agent, and then reducing agents, okay? So now we'll just give you 3 so that anywhere you see them you can identify them as right. Now, number 1 here is potassium permanganate. Potassium permanganate, I'm sure you're familiar with this compound. Reducing agent here is iron 2 sulfate. It's a reducing agent. Now, number 2, potassium dichromate. Okay, we have 2 here, O7. Example here is sulfur 4 oxide is a reducing agent. Okay, another example is potassium iodide. Potassium iodide. An example here is sulfate. Compound is complex. That's why I have to write the name. Okay, thiosulfate. So let me just stop here. If you see these elements, compound in any reaction, know that they are oxidizing agents. While if you see this one, know that they are reducing agents. Okay, quickly, let us perform some tests to show oxidation and reduction reaction. Okay, so when you're doing a practical in chemistry laboratory, you need to wear your hand gloves. Okay, so I'm going to put on my hand gloves now. Alright, so I have here with me, of course, you know this is a beaker. I have two beakers. Now, you have a dilute H2SO4. Of course, you know this is an acid, sulfuric acid. This is the diluted form, and this is our potassium permanganate, the first one. Okay, this is the color, it is purple. Now, you have potassium dichromate. Okay, this color is yellow. Okay, now this is our iron 2 sulfate. Okay, this is our iron 2 sulfate. Now, from the table I gave to you, you would notice that these two are oxidizing agents, and then these two, this one is the reducing agent. So we're going to be performing some practical, and this one will happen in acidic solution. That's why we need this acid. Okay, so first I'm going to start with, of course, two different compounds. Alright, so I will start with potassium permanganate and the iron 2 sulfate. What do I do first? Take a little of this potassium permanganate, pour it into this beaker. Just observe and follow. You see what will happen at the end. So let's say little. Okay. Now keep it aside. Now this is potassium permanganate, is purple, and then acidify it. That means add an acid little too. So you add an acid because it's happening in an acid solution. So this is you shake so that to mix very well. Okay, now this is what we have. Now we are performing oxidation reduction reaction. Remember I told you that these two things happen the same time. So as this one is taking place, the other one is also taking place the same time. Okay, now what do? Add this in a little quantity. So I keep adding small until I observe a color change. So this one is going to change from purple, and then you will see the color. Let me not say it. Okay, so I just add this, keep adding in drop, little by little, and then I shake. I hope you're seeing that. Keep adding little by little. Oxidation reduction reaction is happening here. Okay, now if we look at the color now, this is not the color we started with. Okay, so you keep adding until you see a total change in color. Alright, hope you can see what's happening. Wow, oh, this is beautiful. Wow. Now at the end, the purple color disappeared. What happened? The iron 2 was reduced to iron 3. Okay? And then the potassium permanganate was oxidized to permanganate. Okay? So this is what happened at the end. This is for the first one. Now, we're going to also perform for this. This is another oxidizing agent. Let me remind you, potassium dichromate, and this is still our iron 2 sulfate. Now let's start. Okay, so what do I do first? Put a small quantity of this here. Okay, so this is yellow. Okay, acidify it. That means add little quantity of acid, dilute acid, and then shake. Okay, hope you can see the color. Now we add this ion 2 sulfate and then observe. So okay, just watch. The reaction is slow. Watch. Yeah, it's changing. Okay, now this is the color we are having. Who can say this color? Yeah, this is the color now. We started with, you can add a little again. We have a complete. Okay, this is it. What color is this? I'm sure you echo green. Yeah, this is green color, but in chemistry we call it dirty green. Dirty green because of the way it's looking. Okay, so we started with yellow and then at the end we had green. Now what happened here? The chromate was reduced to chromate 3. Okay, that's what happened here. Now this is it for the test for oxidizing agents and reducing agents. Now let us look at some types of redox reaction. That will be the last subtopic for this very topic. Okay, types of redox reaction now. Okay, let's look at the last part of this topic. That is types of redox reactions. Okay, types of redox reactions. So we're looking at 3 types of redox reactions. The first one is synthesis redox reaction. The second one is decomposition, and then the last one is displacement. Displacement redox reaction. Okay, I'm going to take my time to explain each of them. Okay, so right now we're looking at synthesis redox reaction. Of course, it's a reminder, redox reaction is the transfer of electron from one atom to another. Okay, so in synthesis, this is also called combination reaction. Okay, where you have 2 different atoms coming together to form one. Okay, so I'm going to, of course, I've given you definition. You can write it down. I'll just write the equation. This is also called combination reaction, where you have more than 2 elements coming together to form one compound. Okay, so right now I'll give an example of a reaction that is a synthesis redox reaction. Okay, now for instance, if you have sulfur, okay, sulfur in solid, I've taught you sulfur as an element in your last term. And then remember I told you that sulfur has a yellow color, very beautiful element, and is a non-metal. Okay, so you have sulfur in solid plus oxygen, because oxygen gas. Now, as a chemistry student, you should know the product from this reaction. Okay, what you form or what will be formed will be SO2 gas. That's sulfur plus oxygen will give you sulfur 4 oxide. That's the name, IUPAC name, sulfur 4 oxide. Now, of course, you don't need to balance equation because equation is already balanced. Sulfur here 1 here, oxygen 1, oxygen there, so 1. Okay, that's 2, 2. All right. Now this is first one. Another synthesis redox reaction is the reaction between hydrogen and chlorine. So hydrogen and chlorine gas. So you have H2, of course, a gas, plus chlorine gas. What should come to your mind? Hydrogen plus chlorine will give you hydrochloric acid. Now in aqueous form or liquid form. Now the next thing is to balance this reaction. You're having 2 here, 2 here, 1 here, 1 here. So Very simple, just add 2 in front of HCl and the reaction is balanced. So this is for synthesis redox reaction. I told you that it is a combination reaction between 2 elements. 2 elements coming together to form one. Number 2 is decomposition reaction. Decomposition reaction. Okay. Redox reaction. What happens there? This reaction involves the breaking of a compound to form more than 2 compounds or elements. Okay, so you have a single compound breaking into 2 to form 2 different elements or compound. An example is your calcium carbonate. This is calcium carbonate. I'm sure you know it's also limestone. Okay, calcium carbonate breaks into 2 to form calcium oxide plus what will be left is CO2. Okay, so this is the composition redox reaction. Now, looking at it, you can get other types of other examples for this. You can have a mercury oxide, okay, decomposing into mercury and oxygen. This one is simple to balance the equation. Oxygen is 2 here, 1 here. We'll add 2 in front of this. Now, adding 2 changes mercury, we add 2 here. So the equation is balanced. Now the last one, displacement. Displacement redox reaction. Okay, displacement from the board. What happens? One element displaces another. So it's like changing. One will remove one. So we're going to be looking at 3 different displacement reactions under here. The first one is hydrogen displacement. Hydrogen displacement. What happens when hydrogen is displaced? Now, an example is if you have zinc, okay, plus HCl, which is an acid, hydrochloric acid, okay. Now, of course, this is solid, this is aqueous, and then we produce zinc. We displace hydrogen here from this hydrochloric acid, and then you have zinc chloride plus hydrogen gas. So this is the aqueous. So this one displaces hydrogen from this compound and then combines with this chlorine and then liberates hydrogen. Okay. Now this is hydrogen displacement reaction. Now another one is metal displacement. Metal displacement. Metal displacement. Okay. Now you have a metal displacing another metal. Now I will remind you, now from the activity series shows the activity or reactivity of elements. Okay. Now the elements below the activity series are said to be not very reactive. The ones above are very reactive elements. Okay. Now I'll give you an example for this metal displacement. For instance, you have zinc plus copper sulfate. Now, this reaction can happen because copper is below the reactivity series, so zinc is in the middle. So zinc can displace copper from this reaction to form zinc sulfate plus then copper. Right? This is another displacement reaction, but between metal. This is a metal, this is a metal. Now, because this one is at the middle of the activity series, it can displace this one because it is not very reactive. It is at the top of the activity series. Now, if you have something like this, copper plus zinc sulfate zinc sulfate. Now this reaction will not occur. So no reaction. Why? Why no reaction? Because copper cannot displace zinc. So this reaction will not happen. The last one is halogen displacement. Halogen displacement, that's number 3, and then it will be all for this topic. Halogen displacement. Okay. Now let me remind you, halogens are group 7 of the periodic table. So the elements that belong to group 7 of periodic table are called halogens. Okay. Now you have, first one is the fluorine, and then you have chlorine, you have bromine, and iodine. And if you can remember very well, when I taught the periodic table, I told you that reactivity decreases down the group. So it means the elements at the top are more reactive than the elements below. So in halogen reactivity, you have fluorine, more reactive than chlorine. Chlorine is more reactive than bromine, and then bromine is more reactive than iodine. It then means if you have a reaction where you have chlorine and fluorine, fluorine will displace chlorine from that reaction. If you have chlorine and bromine, chlorine will displace bromine from that reaction. Example, I will show you. Example, now if you have hydrogen bromide plus chlorine gas, now because chlorine is more reactive than bromine, it will displace bromine from here, and then what will be formed will be hydrogen chloride plus bromine gas. Alright, balance the equation. 2 here, 2 here, and 2 here. Okay, so this is an example of halogen displacement redox reaction. So right now I'm going to give you an assignment, and then I expect you to attempt this assignment and submit via my email address and or WhatsApp number. Okay, so this is your assignment. Attempt this assignment and submit via my email address or WhatsApp number. It reads, use the following redox reactions to answer the questions. Roman figure 1, chlorine gas plus potassium bromide produce bromine plus potassium chloride. 2, copper sulfate plus zinc produce copper and zinc sulfate. 3, magnesium plus hydrogen chloride produce magnesium chloride plus hydrogen gas. Now the question is, identify the oxidizing agents and reducing agents in each reaction. Identify the oxidizing agents and reducing agents in each reaction. Then B, describe what you will see during the reaction. What will you see during the reaction? Very simple. Okay, attempt this assignment and submit via my email address. I'll still write it, Jane for God 2008 at yahoo.com, or my WhatsApp number 0809 0713694. Okay, of course you have this. So thank you for watching and listening. I hope you learned something new today. Please make sure you attempt the assignment and submit to me. Alright, take care of yourself, and please remember to stay safe. Bye bye.